Hello, this is Barb Bedwell. I am the chemistry and physics teacher here at South Tahoe High School. And I'm really glad to be able to share a little video overview with you tonight about this brand new experiment known as distance learning or online learning. I just got to say, more than anything else, I just want to say that your kids have absolutely been uh, holding themselves just admirably this week and really trying to adjust to this new online learning and really putting their best effort into it. So this first week has definitely been hard. It's definitely been an adjustment. But I got to say, my students so far have really been game to try to do whatever they could do to participate. And I'm really proud of how they've been doing so far. So good on them, man. It's this is a big adjustment. So my purpose here tonight is to sort of give you an overview and a tour of my course. This is the Canvas shell that you guys are looking at right here, and to give you some ideas of kind of what it looks like, and then to be able to kind of show you some things about how my grades and course is set up, so that you can have some understanding about that. So first of all, this is my Canvas homepage. If you haven't done so yet, it's a really good idea to join Canvas as an observer, so that you can kind of see the Canvas website and see some of the things that's going on with your student. There's a couple different ways to do this. So on the LTUSD website, on the parents page, I believe that there is a link to the resources there that kind of walks you through how to join as an observer, or send me an email and I think I can add you as an observer if you wish, and let me know and I'd be happy to help you with that. Second thing is there's an app that you can use on your phone. It's actually pretty decent to be able to put it on there. It's Canvas Student App, I think is what it's called. It's a nice way to be able to kind of have it in the palm of your hand and take a look at it without being at a computer. If you do use the Canvas app, I just want to mention this real quick. Make sure that when you search for the school, that you type in LTUSD as the school and not South Tahoe High School. Otherwise, you won't find us. So LTUSD is the name of our school, link up with a particular Canvas system because it's district wide for us. So anyway, like I said, this is the Canvas homepage. This is what it looks like. Obviously, I'm using the computer homepage right now, not the app, so they do look a little bit differently. But over here on the left side is kind of our navigation zone. There's some sort of important tools over here on the left, like an inbox for email and some of those sorts of things. And then this main part here is kind of the homepage. So scrolling down, you can kind of see what I do on my homepage. It's not super excited, but I'll change my memes up and just kind of put silly stuff up there from time to time. But at the top of here, I've always got links to our live meets in terms of where we're going to be. We tried Big Blue Button today. I'm not sure that it's my favorite, but I also have a Zoom link here that we can use if we need to. So kids can kind of know when to join on this. My first period class we meet at 8:45. My second period class we meet at 9:45. And we're doing right now about half-hour sessions. That may change as as the year goes on and see what we need to do. Up at the top, we've got some just sort of general announcements up there, and it's just some basic links. But this left side over here is really the part that you kind of want to see, because that'll give you some insight into how the course is set up. In here, other than checking grades, which is one thing, of course, that a lot of people like to go to directly, the organization that I use is through modules. So think of it like a unit. So I'm going to bring up my modules page right here so you can kind of see what this is. I'm going to close this up real quick so it doesn't take up so much space. So you can see right now I have 4 modules that are on here. The first week of school, we did these 2 modules down here, the one that's called orientation and introductory activities. And there was a lot of little things that were in there that were sort of about just getting kids used to using Canvas and navigating some of the different tools and finding some of the different items on the screen and troubleshooting some of the turning in documents. There's definitely some snafus there that we're still working out, but that's okay. It's a new system. Introductory activities was more about reading the syllabus, reading the class policies, recording a little quick intro video so I can kind of see your student's face, hear their voice, maybe hear a little something about what they're interested in. So if you're looking at grades right now, currently that's what we're in that process of kids kind of finishing up these activities. So don't necessarily panic if your kid doesn't have every single thing in, but if your kid has a 0 right now, it's time to make sure that they start kind of picking away at these earlier 2 modules. And the way that I'll arrange it is that the newest modules will always be on the top. So I'll keep adding to the top of the list and the older ones will keep getting bumped down. This general course materials references will always be here. It'll always be the second module. And it's kind of got just like it says, general course materials. So I'll have a link up here where I'm posting like yesterday and the days before, Zoom recordings from our live meets. So if somebody had a question, here's how they can access their ebook and get onto that particular thing, some hints there, some periodic tables. It's chemistry. We use periodic tables all the time. And then some just general links for some of the South Tahoe High School distance learning resources, just so there's another access point for kids to get to that. This top one up here is going to be kind of like a main unit. And so this is sort of intimidating looking, but there's a method. There's a method to this, I promise. So let me talk about chemistry here for a second as a subject, as a teacher. I have to say that chemistry has got to be, is definitely one of my favorite subjects to teach. I've taught all the different sciences. Between chemistry and physics, those are my favorite. But chemistry really is pivotal. It tends to be sort of a gatekeeper subject. It tends to be that, are you on the college path or are you not on the college path sort of thing? And if you as an adult watching this, you probably have one of two different reactions to chemistry. You either took chemistry or you didn't. A lot of people just avoid it like the plague. If you took it, a very small percentage of you loved it, and then the rest of you hated it or survived it. So chemistry is a difficult subject. I know that. That's one of the reasons why I really like it, because it's as a good teacher, it's my job to help sort of facilitate kids making it through this challenging process and coaching them to get what they need out of it. So along with this, I want to mention some things that make chemistry particularly hard. Chemistry is really hard because it's that first class for a lot of students that's really based on abstract concepts. And abstract thinking is very difficult for young people. A lot of people haven't developed that skill fully yet. Yes, you can see reactions. You can see things starting on fire. You can mix two things together and watch them change color. But really, chemistry is about what's happening at the atomic level, and that's invisible. And so learning to kind of picture these atomic level interactions and bonds that are forming and breaking and all that, that's really abstract. That's very difficult to picture. That's one of the things that makes it hard. The other thing that makes it hard is math. The math that we do in here, and we do math pretty regularly. It's not fully math, but I do make sure that we hit a lot of math in here. The math itself isn't really much harder than algebra with story problems. But it's that mathematical thinking that's oftentimes very challenging for students. So, being able to take a look at a word problem and then be able to find the right equations and plug the right numbers in and then do the calculation, that's not necessarily an easy thing for a lot of students to do. So when you combine mathematical thinking with abstract thinking and you put them together in the context of science, that's part of what makes chemistry really intimidating. So I want you to know that the way I've set up the class is to help support students progress through this developmental phase, to progress through this. It's not rote drill and, memorize the periodic table and all that kind of stuff. That's not how kids learn anymore. So my philosophy is mastery-based and standards-based. And mastery-based philosophy as a learning principle or as a teacher means that I really believe that not every kid learns at the same rate and not every kid learns at the same time. Furthermore, it means that kids have different ways that they're comfortable communicating. That was my neighbor. Gotta love online learning, right? So they have different ways of communicating what they know and what they don't know. So there's a couple of things that I have, structures that I built into the class to help support this mastery-based philosophy. So number one, there's an intake process where students have to get information into their heads. And then there's number two, an output process, right, where they have to share what they've learned. And then oftentimes there's a number three, an application process. Usually I like the number two and number three to be combined into one thing, but they're kind of a couple of different bits. So number one, getting information in, getting information back out, and then figuring out how that information is relevant to their actual real lives. So those are the kind of the three components. So the units, the modules are set up sort of in support of that. So there's an intake session, which is like these lesson videos. There's the output session, which is like the standards. And then there's the application importance section, which is the performance assessment. And they are all overlapping and interrelated to one another. So I'm going to kind of show you how this works. So for the input part, I've taken each unit and kind of broken it down into big ideas. They're called standards. And you can kind of see I've got 4 standards in this unit. There's 2A, 2B, 2C, and 2D. And they have different ideas about them. They're all about matter. Sometimes they're 2, 3, 4, 5, depends on the unit, how many standards there are. For each one of those standards, I have then created a lesson video that goes along with that. And that lesson video is me. They're ones that I recorded about 2 years ago now, so you'll see me with my short hair. But I recorded these lessons for students to be able to use, so I know that they're right on the exact grade level that I want them to be and have the detail that I want them to have. So a kid can watch one of these videos. I also then expect them to take some notes as a part of their input process. You have to do some writing as well, and that's really important for brain development, is to participate in the writing aspect of it. And so that's what this note catcher document is for. So now the note catcher document is literally a template that students can use to take notes on. So I've got one of them up here. It's this Chapter 2 Note Catcher for Lessons. I've got a copy of it open. And this is kind of what it looks like. It's pretty much blank at this point. Again, it's a template that kids can use to take notes in. So what is it? Well, there's one of these little sets of boxes for each standard, each video. So standard 2A, I can tell the difference between atoms, elements, molecules, and compounds. There's some boxes in there to fill in, like where did they get their information from? Okay, not every student's going to want to watch my videos. Fine, I'm totally okay with that. Kids have different ways of learning. My style will work for some and it won't work for others. So I don't really care if they watch my videos or if they use the textbook or if they use a different YouTube video or if they have, an uncle that's a chemical engineer that they can interview about it. I just want them to start citing kind of what their source of information was. I don't need any formal citations, but they just write the ebook or Bedwell's video. Okay, great. Down here are the kind of the main parts of this note catcher document, the key concepts of vocabulary on the left, and then the main notes section on the right. So this key concepts of vocabulary, students learn more new words in a year of science than they do in a year of Spanish typically, which is absolutely mind-blowing to think about that. But this is a way for students to kind of start to keep track of what some of those new terms are. There's usually some obvious terms like atoms, elements, molecules, and compounds, but students have different levels of familiarity with the English language and with scientific language. So some students may have 5 or 6, keywords, and some students may only have 3 or 4. That's okay. What are their key terms that they're trying to figure out? In this right side section here is where they're going to type their notes. I do not need this to be like formal sentences. This is not an English document. I'm not grading their grammar at all. That is not the purpose of it. This is a note catcher, not a paper. So it's for them to jot down their ideas. I absolutely 100% recommend or encourage students to do this on an actual piece of paper, like in a real notebook, as opposed to on a digital document, because typing isn't always the best way to record information. But if a kid does it on paper, great. They can use all their different colored pens and pencils and highlighters. They can just upload a snapshot, like literally a screenshot of their notes into this particular square. I'm totally fine with that. Down below is kind of the 2 most important sections, the summary and the unanswered questions. So a lot of elder learners like me know that a summary is really just a restatement of what the big ideas were. It's important that when you try to summarize that you kind of step away from the information and really make sure that it's inside your head. Like, oh yeah, I can tell an atom is this and an element is this. Okay, here's what they are. I don't really need students to use canned language like, today I learned about atoms. Atoms are the smallest unit of matter. Please don't restate what's in the notes. Summarize it. Put in your own words. Let it come out and let it be authentic and natural and actually share what you understand. I especially want you to use the summary section for those aha moments like, oh, I finally understand what a molecule is. That's what you want to write in this spot. Don't just write it because I need it. This should be an authentic document for the student. And the summary is usually that first check. It's the first output. It's the first check for a student to go, did I really understand what that lesson was, or did I just turn into a zombie and just watch it for 5 minutes and then move on? So a lot of times students will say, yeah, I get it. I just can't write it down. It's just, it's hard to put it in words. If you can't put it in words, then you really don't understand it. And so that's what the summary is, kind of putting you on the spot to try to make you phrase it in actual, coherent thoughts. And that's challenging. That's not the easiest thing to do for all the time. So if a student doesn't understand something, a lot of times the writing process will pull that out. Like, I kind of know that atoms and elements are similar, but I'm still really not sure exactly how those words are different. Hey, great. That's an unanswered question. And for students, knowing what you know is important, but knowing what you don't know is actually incredibly more powerful, because that's where you have to kind of dig in, right? So unanswered questions, I'm going to require students to do at least one unanswered question for every section. So something that caught them that they don't quite get yet that they want some more information on. Or If a student is like really easy, like they learned this in 7th grade and they've known it forever, hey, great. Unanswered questions can be hypotheticals as well. It can go beyond the lesson. So are there elements on other planets that we've never seen before? Can you make new atoms? Where do atoms come from? Those sorts of things, unanswered questions could go in there as well. Questions that more pique your curiosity, maybe, rather than identify gaps in your knowledge. But that's okay. That's the unanswered questions section. So this is how kids can practice taking in information, organizing that information, and start the process of outputting information, kind of trying to put it in words and kind of wrestling with their understanding about it. So again, this is a note catcher document. A student would watch a section, get a lesson from somewhere, usually my videos, but again, book or YouTube or wherever, take some notes on that section. And eventually I will grade this and they will get basically some participation points. Not a small number of participation points. This is a lot of work, decent number of participation points for this. But that's what these note catcher documents are. So again, that's what that is a way, an organized way for students to sort of collect information. So once they've got the information in, and they'll kind of progress through these little videos sort of at their own pace. I suggest about a standard a day. If you're trying to pace yourself through a unit, that's a really good place to be. If you put it off to the end and then you're scrambling, it's not the best for your learning, but about a section a day is a really good way to do that. So the output section, well, that's down below. So down here are these standards documents. And now in these standard documents, this is a way for students to share with me what their understanding is. And this is mastery based. So now, again, watching a video does not make you an expert. It doesn't even make you proficient. That's why we don't teach, surgeons how to do medical practice just by letting them watch a couple of YouTube videos. Yeah, I'm good. I got it. Which knee was it? Okay. Mastery is about practice, right? Mastery is about application and challenging yourself to put that out. But mastery is different for different people. So number one, I want you to understand how the mastery grading system works. And number two, I want you to know that with mastery work, students always have the opportunity to increase their level of mastery. So students can get better. They're not going to get worse. But if students make a mistake, that's okay. I want to encourage them to dig deeper and get better and improve, not just accept failure and move on and hope that they never have to take this class again. So mastery is a really important philosophical concept, as well as an important grades level concept. So there's a document here that says mastery levels, and there's some information on the mastery standards. But the mastery levels kind of look like this. What we really expect a student to do is this: we expect them to function at the proficient level. Back in the old day, we used to call that average. You'd get a C, 75% for that. But now we're calling it proficient. And I want you to note that I'm going to give an 82% on any standard based on this. It's a B. It's a low B. It's not a comfortable B, but it's not a C either. It's a decent grade, and it means hey, I get it. I'm fine. I'm not outstanding. I don't have a ton of knowledge, but I basically get chemistry at this particular concept. It means you got it. And this is what I expect every student to be able to do. Not every student can do this at first. A lot of times students make mistakes. And so they might get a developing proficiency, or they're just way off the mark. They get a basic proficiency at 2.0. So you can see that those are worth lower points. They're not worth as many points. But again, if a student almost is there, then go back and fix it. Go resubmit it. I will regrade it and bump you up to that next level. There's a fairly big gap between these two. I want to encourage students and support that idea of increasing their learning. The higher levels, the 3.5 and the 4.0, are optional. Students do not need to do these. If you're just trying to get through chemistry, get your physical science credit and graduate, proficient will get you there, man, and it's totally fine. If you're thinking about being a science major or studying sports med or kind of getting into any of the medical kind of fields, any of that stuff, you're going to want to be thinking about kind of working at that higher level. And this is your chance to really really get excited about chemistry and show me some really cool stuff that you understand. But again, these are optional, and students can choose to do these or choose to not do these. They don't ever hurt you, but they are definitely worth more points. So here's what one of these standards documents look like. And this is the output section. This is where a student shares with me what they have learned and understood. So you can see at the top, I pulled up, this is the standard for 2B is the one I just happened to grab. So at the top, the standard is stated there, and it's been stated on other different things, but this one's about solids, liquids, and gases. This one gives you some prompts, like here, tell me about these couple of things. If you can explain this in your own words, then you pretty much understand what the standard is. So that's what the proficient is. It's important to make sure that students learn to read directions and answer both parts. If you haven't done both parts, you're not really proficient. So, if you're a surgeon and you can only do surgery, on the knee, but you can't do the ankle as well, then you're not really proficient at doing the lower body. You got to do both the parts. So there's the proficient spot. They could type it right in here. They can do a lot of different things. They don't have to write it. They could record it. They could do a little video. They could build a model. There's a variety of different ways that students could demonstrate this particular bit of learning, depending on what they want. But they would do the proficient level. And if you get that, if you do those parts and do it correctly, you get that 82%. Here at the bottom of the standard, you'll see that there's the prompts or suggestions for the advanced and expert levels. And again, these two down here are optional. Students can choose to do them if they wish, but they don't have to. Every student is expected to do proficient. Students that are at that higher level can do the advanced. If you know you're going to do the advanced part, I kind of suggest you read these in advance, because a lot of times in answering the top part, you can also wrap in the answer to this one, the advanced one, and get that next level of credit as well. So it doesn't necessarily mean you have to do a bunch more work, but you do need to be more thoughtful and usually have a deeper level of understanding, a little bit more depth to your explanations perhaps. So that's kind of what one of the standards documents looks like. So again, in this particular first unit, we have 4 standards, which means there was 4 videos, 4 sets of notes that kind of go with those videos. And then there's 4 of these little standard documents. Show me what you've learned. Okay, the last part, I don't have it up here yet because I don't want to freak everybody out. It's early in the year. It's overwhelming enough as it is. There will also be a performance assessment. In the online section here, we're probably not going to do a lot of testing because I have found that testing is unreliable and invalid. It doesn't, kids can cheat their way through the system too much. It's not authentic. It's not really like telling me something about what they actually know. So the performance assessment will be the application side of it. Get excited about something and apply it to this. So you'll be able to use these standards through the performance assessment. We'll be doing one based on elements, critical elements that are either interplanet or endangered elements that are required, like what are the elements of your cell phone, or why are things radioactive, or how do we make new elements? And students will be able to do that more in depth through the performance assessment. As we get later on in the year, or in the semester, the performance assessment and the standards will be presented at the same time so that the students will be able to do the standards demonstration through the performance assessment as opposed to in a separate assignment. But for right now, as we're sort of rolling it out, I do have them separate assignments for now. So again, I really strongly believe in that idea of project-based. Make it important, make it authentic, make it something that you're interested in and that you care about. And that's a way you'll be able to demonstrate that. I do hope at some point in time that we'll be able to do some labs. That would be wonderful. Hopefully in October here, we'll be able to get back in the classroom and do some real hands-on stuff. I'm exploring options for some virtual labs or some simulations. They're not as good as the real thing. So if we go back to a hybrid schedule at some point in time, probably what will happen is that the online days will be based on doing this kind of work, and then the in-person days will be doing the lab work, and we'll sort of be alternating days between our groups. So now you've kind of seen that idea about sort of how the class is set up, some of the different kind of sections to it, my passion for mastery-based learning, my passion for science, and how to get some of that information and sort of how it's sort of organized. But your students can submit and resubmit. They can grow and gain and get better. It is not a one and done with any of these sorts of activities. So it's really about, like I said, authentic learning and trying to be able to really take that and internalize it as best you can, and giving your students the flexibility to be able to be successful in that mode. I'm trying to think if there's anything else we need to talk about today. In terms of norms and things like that, norms and success, tips for strategies for success. We have a Zoom meet every single day. It's only about a half an hour long. Kids are on Zoom a lot right now. It's a lot of computer time. But it's a way to check in, and we can go through some of our more challenging topics, or just a way to check in with them as human beings and see how they're doing, so that I can kind of get the pulse of how the class is. In terms of success, you as a family member, you do not need to know a lot of chemistry to help your student. What you need to do is help support your student as they progress through this growth and development, this learning process that they're going through. Help them learn to access their resources. And you can ask things to your students like, well, what have you tried? Where did you get your information from? What does your lesson look like? And then you can ask questions like, well, who can you ask for help? I am very responsive via email, but I encourage students to help each other as well. A lot of really good learning goes on between peers, even if it's done over FaceTime, over a Zoom call or something along those lines. And lastly, I want to say some other tips for success. It's really important to make sure that we emphasize the positive about all of this distance learning stuff that we're doing. This is not anyone's choice, but there's some really good things about distance learning. The flexibility and the ability to take control of the pace and time of your own learning is an incredible gift. And if we can remember to go outside every once in a while and get some exercise in between our classes, I think that's awesome. And I think that's a really good thing about this independent learning. The other thing that's really good about this is it really teaches kids some real world skills like problem solving and resiliency and basically self-reliance, to be able to take charge and control of your own learning and recognize when you understand something and when you don't. Most of my students are sophomores and juniors. They're going to be going to college in about 2 years, and they're going to be completely independent at that point. So anything that we can do right now to help them develop those self-reliance skills, and be able to check their own understanding and pursue their lacks of understanding, that's incredibly valuable. Those are skills that they will use for the rest of their life. Not to mention the technological skills, right? These guys are going to be better able to live in a digital world than any of us older folks will ever be. And I guess the last thing in terms of student success, the students that have been successful in the past with online learning, number one, they set up a schedule. Make sure that you work with your students to help them create a schedule that fits them. They need to create the schedule, though. Mom and dad, parents, you can't create the schedule for them. This has to be from them, their schedule, their time. What's going to work for them? Do they need frequent breaks? Do they need big blocks of time to work on stuff? But help them build in a schedule, and then make sure that there's some balance in that schedule too. They need to get away from the computer. So time to get outside, time to exercise, time to see other human beings either in the family or on Zoom or whatever they do, or to pursue their hobbies. One of the cool things about online learning is it is more flexible. Take advantage of that. So make sure to build balance into that schedule. But when students come up with the schedule themselves, it tends to be a lot more authentic. So make sure that you're kind of working on those particular things. And then reach out for help. Make sure that with this kind of learning that you don't wait and hope that it goes away. Communication is one of the most important pieces of online learning. Reaching out to your teachers, reaching out to your peers, colleagues, other families, and communicate openly in advance. That's the mature way to deal with issues that come up, as opposed to just kind of closing the computer and walking away. So, like I said, it's going to be okay. We're going to do fine. This is not the worst thing in the world that's happened. We'll come back to school here eventually, and we'll be able to do some labs. But even if we don't, this isn't a bad way to learn, and it is possible to learn in this mode and to really gain from this particular process. So there you go. Thanks for watching this tonight. I know it was a little bit on the longer side. So if you need anything from me, please don't ever hesitate to send me an email. It's bbedwell, BBEDWELL, at ltusd.org. You can reach me through Canvas or the school email website, whatever you want. And I'm here to support you and your students in their learning as we move through this crazy 2020, and we'll make it out on the other side. Thanks for being here tonight. Have a good one. Bye.